Hello everyone, and thank you very much, Janusz, for the kind introduction. And also, before we get started, I'd like to thank you very much for all of you on the line for taking the time to listen to our webinar today and learn about what type of query features you can build in ChemAxon Tools. Because as we all know, we quite often are faced with problem to search large libraries of molecules, looking for hits, looking for certain features, looking for certain parameters and properties. And in today's webinars, you will learn how ChemAxon Tools offer sophisticated query features to improve the quality of your hits return and make the search more time efficient to basically reduce the number of sequential query which are typically employed. For that, I put together 3 case studies, something which is more common as end user which you're facing every day. Basically, usually you're looking for compounds of interest in databases or searching using Markush query features into patents and research papers. And last but not least, looking and searching reactions, for example, in virtual compound libraries, or if you wish in electronic notebook fashion for a point of view. But before I will go and do the case studies I put together, I would like to give you a little bit of introduction of the tools you'll see during this webinar today. First of all the queries which we'll perform and you'll see will be done in InstantJChem, which is basically our out-of-the-box desktop application designed for scientists, by scientists for scientists, even if you are a biologist or chemist, to help you manage your data. We all know that we have so much data we have to look at, to query, to filter, to analyze, to share, and to report, and that's what InstantJChem will do for you. It's fast and scalable, can bring you data in your desktop right away, and you can use its powerful search and rich chemistry functionality to basically do your day-by-day job easily. If you want to find out more about the product, please go and check our product page on InstantJChem on ChemAxon's website. Another tool you'll see today, which is embedded into InstantJChem, it's Reactor, which is our virtual reaction enumeration engine that supports generic reaction, but also combined with reaction rules, and also it's capable to generate chemical feasible products with without preselection of reagents. Also, it's able to carry out the highly automated reaction enumeration, as well as manual selection for a given chemical reaction. Again, if you want to find out more about this product, please visit our website. But mostly what you'll see today, you'll see Marvin Sketch, because all of the query features I will show you today will be actually done in our advanced chemical editor drawing package, which is Marvin Sketch. You can draw here chemical structures, you can draw query, you can draw reactions. And there are tons of capabilities inserted in Marvin Sketch. I have here just a list of a few parameters, a few features which are embedded into Marvin Sketch. And I would like just to quickly go through the list and make you aware how powerful our drawing sketch is. First of all, supports a lot of chemical file formats. I can basically use all type of chemical structure file formats. It has a checker which will check your structure and your valence of the molecules you're drawing, but also it has a standardizer embedded, which help you to use rules which are already predefined, but also allows you to build your own rules to basically standardize the molecules you're drawing. Property calculations are included, from simple physical chemical property to more complicated one. Abbreviated groups, built-in user-defined templates library are available as well. Markush structures, sketching and representation, and 3D manipulators, and also searching directly in public databases like ChemSpider and PubMed are just a few examples here. And also research and publishing capabilities, from image generation to display and formatting structures, things like that. So there are a lot more. Please check our website, again, the product page for Marvin Suite as well. And the last two tools you will see, or technologies you'll see today, be Markush search and enumeration technology. It's a powerful tool for searching structure in large chemical space, usually defined by generic Markush structures, without actually having the need to enumerate the explicit compounds. Again, you can find out more on the Markush product page on our web page. And the last one is document to structure. This is our new technology, which allows you to extract chemical information from documents. And that could be any text. You can search for text OCR and image OCR. And the technology is so powerful because it can extract information even from non-searchable PDF documents. For example, if you have PDF documents which are very low resolution or they are scanned, the technology will work on those files and will extract the chemical information from those files as well. With that, let's go and look at our case studies we have prepared for today. And we'll start just a simple compound search in databases, because even if you're in industry or even if you're in academia, you have so much data, and usually everybody has gathered together this in a database, or and not just simple spreadsheet, but you can imagine that you can use the technology even in common spreadsheets as well. So let's take a look and see what type of queries you can build and use in ChemAxon Tools. As you can imagine, structural search atom by atom is supported, and not just substructure search is supported. You can do also superstructure, you can do a full structure search, you can do a full fragment, you can do a duplicate search as well. So this is actually most common queries you can use and build with any other tools from vendors. But actually what distinguish us from other vendors are the complex query, which you can build and use in ChemAxon Tools. As you can see here, it's a parade of atomic features you can build. So not just atom by atom query features are supported, but also you can query for any atom types. So basically, the advanced menu of the Marvin Sketch allows you to search for any atoms, or you can go even more focused and search for any halogens, any metals, any heteroatoms. You can build lists, you can build periodic table groups, and so forth. More than that, you can use pseudoatoms. You can search for examples of resin or carboaryl or carbo carboxyl groups and things like that. You can search for explicit lone pair structures, so that will match and will imply lone pair as well. You can search for compounds which have charges and isotope and radicals, and also or compounds which have link nodes in it as well. Besides that, you have other even more options. You can search for stereochemistry. You can keep the stereochemistry on, you can keep it off, you can do an exact search, you can do diastereo merge search, and so forth. Opposite to searches for structure with charges and isotope and radicals, you can ignore them. You can ignore the valence as well in polymers, and you can do a search on that as well. VAG bond matching options are supported as well. So you can specify a bond to be a different type, any type, or just aromatic or aliphatic. You can use chemical terms, filters. Basically, you can search for other properties which are associated with your compounds into a spreadsheet or into a database. You can do a tautomer search. You can keep the tautomer on and off, and you can search just for tautomer structures. You can do inverse his list, and so on. More than that, you have some other atom query properties. You can assign if a chain will terminate in an aromatic or aliphatic mode. You can assign the ring count and the ring size. You can assign the valences and the ring bonds count and substitution count. So many query capabilities are available in the advanced panel of our tools. And last but not least, you can do logic queries as well. So for example, if you have a different hit list, you have, for example, 2 query lists, you can use logic operators to do an intersection to find out compounds which overlap the 2 queries you perform. You can look at the union, so you can look at all the compounds on both lists, or you can do the exclusion, or you can look at the compounds which are relevant just on your one of the query lists, and so forth. So let's do and actually go and see some of these queries, how we can build them live using the tools. And as I mentioned at the beginning, we will perform the query features into InstantJChem, our desktop application to manage your data. What you're seeing right now on the screen, it's my working space in a IJC project, where basically on the left side I have my data trees. So I have some lists and forms built which will extract data directly from a database. So what you're seeing on the screen right now is just a list of almost 10,000 compounds for which I want to build some query and search for some structure. I'm right now in a browse mode of my InstantJChem, where I can visualize the data, but I can easily switch on the query mode, where I can start building queries and run the queries to perform some searches. If I'm double-clicking on my structure field here, that will pop up Marvin sketch, and I can start building queries to filter my list of compounds here. So at the beginning, let's just do an atom-by-atom search. In this case, I have a formic acid fragment. I will quickly set the query. As you can see, I'm performing a substructure search. In this case, I can easily run the query and see that right away the InstantJChem engine filter out all the compounds which contain the formic acid fragment. So I have around 1,162 compounds out of almost 10,000 which contain that particular fragment. But I can do some other type of search. I can quickly right-click on a substructure, and right away I have a drop-down menu which helps me to switch from a substructure search to superstructure or similarity or duplicate, a full search or a full fragment as well. In this case, let's perform a full fragment instead, run the query, and I see that I have 81 compounds which have the formic acid associated with with my structures here, maybe as a salt or something else. Let's start and do a little bit more complicated queries. So for example, I will search for phenylpiperazine molecules, fragments here. So I'm quickly drawing that. I can use my keyboard, and instead of clicking on the atoms here, I can just type on my keyboard N, and I'm assigning the nitrogens. I can set the query. I'll go and do again a substructure search. And you can see I have 800 hits right now, which contain my fragment, fragment of interest. But also, not just simple substructure search, let's do a similarity search and see if we can find any similar compounds in this list of compounds I have here. I can easily select in the option menu what type of configuration. If I want to do a Tanimoto, I can do a Euclidean, or I can do a normalized Euclidean substructure and superstructure search. I can easily set up the threshold. So very, very easy. I can run the query again, and I can see that I have 23 compounds which are quite similar in my list of compounds here. Also, I mentioned that not just structure search is available into ChemAxon Tools. Also, we can add some chemical terms. So for example, if we go to the query panel, I can use the query manager, and I can set up some chemical term filter here and filter some other properties which are associated with my list of compounds. I can write my expression here, but also I can pick one of the rules which I already saved. In this case, I can use Lipinski rule of 5, which probably most of you are very familiar with. So I can choose that. But also, in each particular field, if I'm right-clicking, I can now have available a list of operators, and I can further filter my my queries, so I can refine my queries using the operators available. So let's say that I'm not looking just on the molecular weight, which is less than 500. I can actually select to do between. I'm sorry. So I can say I'm looking actually for compounds between 100 and 400. So I can easily assign any other query filters in all of these fields here. So all are queryable, and I can add any parameters I want. Running this query, I have 76, actually even more examples, 254 compounds which satisfy my criteria. So it has the molecular weight between 100 and 400, and also my substructure search, my fragment included as well. Another thing I want to point is that if you have different data trees in your project, you can actually do simple federated queries and search. So you can search on multiple data trees and multiple lists of compounds. You can easily select in what data tree you want to do the search. You can specify the criteria here, and you can basically simultaneously search on multiple data trees. So that it's supported and really easy. So you can see now that I have in my list here, an example list, I have 824 hits, and in my the other list I have 85 hits. Let's go back to our initial list of compounds. Let's clear this query, and let's try to build even more sophisticated queries. So we saw that atom by atom is supported. It's very simple to build the queries to build the options and so forth. Let's say I want to do an R group decomposition, and basically I want to look for compounds which has this particular fragment. So I have my benzene ring and I have 3 R groups attached to it. Again, I'm using my keyboard to assign the R groups, but easily I can do that into my advanced panel. So I have all my R groups available here, so I can pick one by one and assign. But the shortcut is even better. So I'll set the query. I will run it, and see that right away the R group decomposition is supported, and my structure column now is divided in 4 columns. I have my core here, I have my scaffold molecules, and also next to them I have my R groups listed. Even more, let's go and do even more complicated queries. I mentioned that homology atoms are supported, so let's see that. So again, I have my benzene ring. I'm looking for any halogen in this position. Again, I'm using my keyboard and I'm pressing X, which means any halogen. But if I'm going into my advanced panel, I can see here the generic query atoms. And if I'm mousing over X, I can see that this means any halogen. As you can see, if you mouse any button here, you can see what features, what represented, what you can pick to build your query. Let's make it a little bit more complicated and add an oxygen here, nitrogen here, and let's add a special node here. So let's say I'm looking for carboaryls in this position. I can set the query. I can go in option mode, and I will ask for homology neurotranslation in this case. Running the query, that will return 30 compounds which satisfy my criteria. I have even iodine or chlorine, as you can see on my position here. So I ask for any halogen and also any carboaryl groups attached to the link here. Also, I mentioned that tautomer search is supported, so let's see that as well. Let's say we have this particular query. I'll put the chlorine here. Again, I'm using my keyboard or shortcut, so it's very easy and handy to use Marvin Sketch to draw the query, as you can see, or draw structure. I have a nitrogen here. I am assigning here a double bond and another bond here. And also, I will add a double bond here and attach nitrogen. I will set the query, and I will go in the option menu, and I will ask that I'm looking actually for tautomer, so I'll set the tautomer to on. So very simple and easy to do that. I'll run the query, and you can see that I have 2 compounds to satisfy my criteria due to this amine form in this position here. Even more complicated ones. I told you that stereochemistry is supported as well, and just to speed up the process here, I will start and import some examples here. As you can see, I'm looking for stereocenters. In this case, it's very easy to assign that. If you right-click on your stereocenter, you can assign the stereocenter to be R or S or keep it off. It's very easy and handy to do that. And I will set the query. And I will go and check in my option menu that I want exact stereochemistry. So I will run that. I can see that I have the compound selected. Or I can keep the stereochemistry off. I can run the query, and now I have every single possible combination. A few more examples here. I mentioned also that VAG bond is supported as well. So let's see that. So let's draw decahydronaphthalene here. Set the query. Go again in the options. And I can set now my VAG bond to be off. So I'm searching for an exact match. As you can see, my list contains just the exact match. But if I'm switching my VAG bond to ring bonds or aromatic, I can see now that I have a combination of all the possible rings here, which has aromatic bonds or non-aromatic bonds. A couple more in this section. I can now open another example. I'll explain you in a second while I'm looking here. The query I build basically has has a aromatic or single or double bond in this position, so you can easily select that and modify the bond to be single or double. I have here a list of compounds. I can easily do that by mousing over the atom I want to create a list on. And using, again, my keyboard, I can type carbon, comma, nitrogen, comma, sulfur. And I can easily create an atom list. Or again, I can go in advanced mode and use the atom list from here. Also, I can assign various positions. As you can see here, this bond could be attached to this atom or to this atom. And very easily you can do that by selecting the atoms you want to send the variation bond. You can right-click, and in the Add panel, you can select Position Variation Bond. And more than that, to make it even more complicated, I can add link nodes, as you can see here. Again, very easy to do that as well. You can right-click and add, you can add link nodes. So there are a lot of capabilities, up to 100 nodes you can add. So in this case, we're looking for a node between 1 and 3 bonds. So let's set the query. Let's run it and see that. Oops, probably I forgot to get the other one. Oh yeah, I did a mistake here. I assigned. Okay. Run the query and see that I have 100 hits, which basically look for only any combinations I set in my query. Last example here, I mentioned that also pseudo-atoms can be created and used in the query. So for example, I can add here any type of atoms, and then even more, I can edit its property and add additional nodes. For example, I want that the number of occurrence of nitrogen in the ring to be between 1 and 2. And also I can assign that the number of atoms in the ring system to be between 3 and 5 in this case. So I can easily assign that and set the query. I can run it. Again, sorry, should have cleared the previous one. And I can run this as well. So these are just a few examples in how to query for structures in chemical database. Let's go now, because the time is flying. Of course, there are many other features we can show here, but let's go and look at the second case study, which is searching patents and research papers using Markush query features. Our Markush technology fully supports various types of Markush structure variation. And just for you which are not familiar with that, Markush searches or Markush structures are generic structure, which basically are used in combinatorial chemistry library or in the chemical patents to define large chemical spaces and usually to protect the intellectual property. Our technology provides a powerful Markush structure analysis and to import and to rapid search these structures. And also I'd like to mention that we have a collaboration with Thomson Reuters, and our technology supports 100% and it's compatible with all the patent features in the Thomson Reuters databases, including the Markush database, the patent document, and exemplified structure databases as well. Here is just a simple example of a US patent where you can search for complex queries. You can see that I have multiple R groups, and I can define what each R group can contain. We'll say that in a minute. So what are the query features? A few of them which are supported in our technology. Of course, atom list and bond list. This is something really common in the patents. They're possible to be searched. You already saw that. And different possible atoms and bonds are searched in the same location. Also, position variation bonds, these are supported as well. Moving further, link nodes for more simple one to more sophisticated one. But most important one are the complex R groups. For you which are really familiar with the patents and the way that the structures are represented, this is something which is really common to search into the patents. And as you can see, R group with multiple attachment points are supported, and you can go to many of them. As you can see in these examples, we have up to 48 R groups attached. And last but not least, homology group, again, pseudo-atoms that represent generic groups are supported, and all are consistent with Thomson Reuters homology group definition, which are used in patent indexing. So again, let's see some of these features live. I am going to switch now into my data tree where I have a bunch of patents and inventions. Set it up. So basically I have a form view here where I can see structures, I can have the title of the patent and some other important information. I don't want to go too much in detail because the focus is to look at the query features and how we can query in a patent. So again, very simple. If I'm going the query mode, I can open a structure just to speed up the process. I'm not drawing it. For example, let's look for bumethane compound. I can run a query, and I can see that I have a patent which satisfies my criteria here, which contains new phenyl diazepam carboxamide compounds, which are dopamine D3 antagonists to treat schizophrenia and depression and Parkinson's disease. So this is basically kind of an atom by atom search, but we can go and build even more complicated queries. So for example, I have here any type of bond, I have list atoms, also I have heteroatom notation here, and more than that, I can assign that the terminal chain here can be aromatic, and that's very easy to assign. If I'm going into my advanced mode, I can look at the atom query properties, and I can assign if my terminal chain, if it's aromatic or aliphatic. So very easy to do that. Or using the keyboard, I can just type point A. You see that a list of abbreviations are shown in the screen already. So again, if I'm in point A, that it means will be aromatic, and I can assign ending chain to be aromatic. I can set the query, I can run it, and you see out of 300 inventions, I have 2 patents which satisfy my criteria here. So very simple. So quickly, let's look at another example here. I can open another file, another query. In this case, I have position variation. As you can see, it can be between these 3 bonds, and also I have an atom list and a link node. I can set this query, I can run it, and again, I'll have a list of invention, set it up. So you see that it's taking a little bit longer because my query is a little bit more complicated than previous ones. So it's looking and searching for all the possible combinations and see if it can find something. And indeed, it find 6 patterns which satisfy my criteria. Probably a last example I want to show is in this section here. It's one using different R groups with different attachments. So as you can see, I have 2 R groups, and I define here the R groups I'm searching for, and also this R group has 2 attachments. But as I showed in the slides, you can assign as many attachments as you want. So we can build really, really complicated ones. So I'll run the query, and again, I have 4 patterns here which satisfy my criteria and which are returned as a query result. And it's much more to show here. This is just a few examples. I just want to jump here on my last example about searching reactions as well. So that's supported in our tools. Again, Reactor, it's our reaction synthesis tool which allows you to build reactions on your desktop. It's available as a standalone application, but also could be integrated, and it's integrated in NIME nodes and Pacman pilot nodes as well. Also, it's supported into JChem for Excel, Instant JChem, and via API. And basically what it does, it takes a list of reagents. For example, we have list A and list B, and using different synthesis paths, you can build any possible combination and get product out of the list. Quickly about what type of searches you can query features you can build to search in reaction. Basically, substructure search in reaction equation is supported, and it's exactly the same as a classical substructure search process. And will match any reaction component, even if it's in a product, in the reagent part or the product part, or even into the agents. But also you can search in specific parts of the reaction. You can search just on the reactant sides, or you can search just on the product sides or on the solvent sides as well. So that's supported. You can also search for disjoint fragments, or multiple products or multiple reagents at the same time. That's supported as well. More than that, if you have atom maps, so if your query has mapped atoms, the reaction center of the matching reaction is actually mapped correspondingly to your reaction as well. If you have stereo centers, you can also assign stereo center query features, and so that's supported as well. And last, the center bonds queries features are supported, where basically you can apply reactant center query features to on bonds to express the bond's role in the reaction mechanism. So let's quickly look at that as well. I am opening up another project here. So I'll go into my recent projects and I'll open the reaction project and see that I have here a list of reactions. So I have 185 reactions I can query on. I can go on a query mode, and let's query just simple, just delete everything here. We can simply query on the toluene, for example. You can see that if I'm running the query like that, the toluene fragment, it's actually searched both in the reagent sites and at the product site. If I'm actually going and assign an arrow, and I'm asking to do the query just on the product side, if I run the query, I see now that I have actually my fragment highlighted and searched just on the product side. So it's very simple and easy to do that. Fragments are supported, as I said, so if you want to search for multiple fragments or disjoint fragments, you can do that as well. So let's do a simple fragment here. Let's put an oxygen, and let's put the nitrogen here and set the query. You can run it and you can see that the search is done and both fragments are searched in my reaction library here. And probably the last thing I want to show today, it's how easy you can assign queries for reactant center bonds. So I'm just having a simple structure here. Let's put another oxygen. And if I'm right-clicking on the bond, I can assign the reaction center, so I can search for make it or break it, or no center, or make and change, or change. So very simple to do that. I will just do a search on the center for example, and now I have, as you can see, 5 reactions which satisfy my criteria to have the reactor center bond. So I think that's all for today. If hopefully was interesting and raise your expectations, and also make you curious to find out more and read more about query features which are supported in ChemAxon Tools. There is a lot of literature out there on our web page. You can quickly search for query feature or Markush searches or Markush reaction. These are just some examples. So a lot of documentation and literature, it's available and ready for you on our website. But also, if you have other questions and you want a more focused demo, we're more than happy to do that for you. Please contact us at upside-support@chemaxon.com, and we'll be more than happy to follow up and have further discussion with you. With that, I would like to thank you very much for today. And I'm more than happy to answer to any questions you may have. Thank you.
Yeah, thank you very much, Aurora. And I would add, of course, if you have any questions regarding this webinar and presentation, just type it to the question box. We're going to be here waiting for a couple of minutes for letting you enough time to type your questions. In the meantime, I will repeat some part of my intro that you will get a follow-up email on Monday, and it will contain the slides and the video of this webinar. So there you will have the chance to watch it again, and if you have any questions, you can drop us a line or use our support forum. Thank you. You all pretty much know channels. But there is our first question. It goes like, what databases are searched for retrieving the results of structure search? Please give details of databases covered.
So any type of databases are supported, so we can hook up any internal database. Oracle, MySQL, Groovy, these are all supported. And of course, you need in the cartridge. You can use our cartridge, JChem cartridge, to basically have all these features available and queryable for you. I hope that answered the question. Please, if you need a follow-up on that, or have need more explanation, I'm more than happy to follow up after that.
Yeah, that's correct, and I think that we do not we do not receive any new questions, so I would like to thank you very much for your attendance, and I hope to see you back either on our upcoming webinars or in person in our user group meetings. See you back on these events, and have a really great day wherever you are in the globe, and take care. Goodbye.